So welcome to From Code to Crime, exploring threats in GitHub Codespaces. Today we'll be talking about an interesting abuse of GitHub platform, which is different from GitHub Actions and the way GitHub repositories have been abused in the past. So did you know that with any GitHub account, okay, first of all, how many of us have had a GitHub account? Well, that's fair enough. So did you know that with any GitHub account, you could create 2 Azure virtual machines for free since November 2022? So that's what we'll talk about today. So we are threat researchers with different areas of focus. My name is Nitesh. I focus on all things cloud containers. And I have my friend Jaromir. He focuses on the malware side of things. There's a couple of conferences that we've been to and our socials. So we'll dive into the outline. So the outline for our talk looks like this. We'll go through some introduction, some overview, the ways these cloud-based IDEs are being abused and can be abused, some malware campaigns that we have observed, hunting tips, and we'll drop to the conclusion. So IDEs solve problems for developers, integrated development environments. People use it as source code editors, debuggers, build automation tools and all. So first of all, it helps developers exit Vim. Like, no offense, please don't get me wrong. Secondly, they help developers get more efficient. For our session, we'll equate web IDE or online IDE or cloud-based IDE. So cloud-based IDEs are virtual machines, development environments hosted on cloud, and you can access them from your browser itself, or there are various other ways to access it. The interesting bit here is that you can start off your projects really quickly and you don't need to be dependent on a slow machine or something. So for the developers, it's not very important for you to have a Mac all the time. You just need internet and a browser. That's it. You can code from anywhere with just browser and an internet. And cloud-based development environments may also be the future as well, as we see in this Gartner report. So again, no MacBooks for everyone. There are many options out there for cloud-based development environments. And in this talk, we'll particularly focus on GitHub Codespaces. So a Codespace is a development environment that is hosted on Azure. So developers can connect to these hosted environments using their browser, their VS Code, the VS Code IDE, the JetBrains, or the GitHub CLI as well. So you can create your environments, which is basically a Docker container in which you have all your tools, utilities embedded within the container namespace. It enables coding from anywhere, which is pretty cool. And it also lowers the barrier for folks to get into software development. The interesting bit here is, unlike Azure, AWS, or GCP, or other public cloud providers, there is no credit card or payment information that is required to create a code space. And this bit will get interesting as we move further in the talk. Since any user, any free GitHub user can create code spaces, we posed a question to ourselves: what could a user with malicious intent do? Since there have been numerous instances of GitHub abuse in the past, it wouldn't take long for attackers to go to Codespaces as well. So we switched sides, and let's now take a look at Codespaces from an attacker's point of view. From just the browser, you can access the Codespace, and this is what it looks like. So you have the browser, you have your terminal, your workspace, and everything right from the browser itself, which is pretty interesting. And one can create Codespaces and deploy them in numerous regions. Like we have these 5 regions here, and we have different virtual machine configurations as well. So these are the various options that you see when you create a Codespace, when you have a free account. Additionally, the default idle timeout, so the number of minutes or the hours for which your Codespace will be running after you have left it idle, is the default is like 4 hours. And the default retention period is set to 30 days. So for 30 days, your Codespace won't be deleted once you have stopped it. So when one creates a Codespace, a virtual machine and certain amount of storage is assigned. And on this virtual machine, there runs a container. And as you know, with containers, the first instinct is to see that whether we can get onto the underlying host. So we see that the Codespace is a privileged Docker container. And privileged Docker containers, we have been very much familiar with, as they allow any user in the container namespace to escalate to the underlying host. But the interesting bit here is that Codespace VMs are not shared. So even if you escalate from the from the container to the underlying host, you don't see someone else's working area. And this is a POC that we crafted based on the honeypot attacks that we have seen in the wild in the past. So there are certain features that we'll talk about. The first one is exposing or forwarding ports. So in this example, I just start a Python-based HTTP server listening on port 8080. And as soon as I start this server, I get this prompt that, hey, your application is running on port 8080 and you can view it. This is a very helpful feature for developers to help, test or debug their applications as they build it. And there are certain ways in which you can set the visibility of the port that you are exposing. The ports can be forwarded in 3 different ways. Private, that is just like accessible to you. Private to the organization. So anybody who knows the entire URL of that exposed port can access the port. And public, that is exposing the ports without needing any authentication context. It is interesting to also note that from the forwarded port URL, you can figure out the username, the code space name, and the forwarded port. So you have the username followed by the code space name followed by port separated by hyphens, .preview.app.github.dev. Additionally, if you notice, a privileged network attacker can also view that which GitHub account is actually working based on the DNS requests as well, because this part won't be encrypted. So Cyber Threat Intel folks, CTH folks, does this look familiar, directory listing? Well, open directories have been in the news for a very, very long time. And while observing this feature of exposing ports on a code space, we had a question like, can we hunt for exposed ports on a code space? And we found out that was not really possible. So in this example, I start a Python-based HTTP server listening on port 8080. I set the visibility of the port to public. And then I view the IP address of this code space that I'm running. So it starts with 98. Then I do a reverse lookup on this exposed port URL. And there I get an IP address that starts with 20. So that is different from the IP address of the code space. And when I try to visit this this IP address on HTTPS 443, then I'm greeted by the Kubernetes ingress controller. So what this basically means, let's say a user has 3 code spaces. To access any of these 3 code spaces, the user will be greeted with an inline proxy. So this also means that there is no way for anyone to access a code space by its IP address, which also makes sense because a user can create n number of code spaces. And then if every code space gets assigned an IP and then you can access it by the IP, does not make sense because that's not how modern scalable systems are built. And we also found that IP-based fingerprinting will not be effective in finding exposed ports on a code space. So we could not find relevant results on Shodan senses as well. And we had some internal simulations wherein we could abuse code spaces as C2 servers as well. We reported this to GitHub, but it seems like an accepted threat model. We are not really sure about that. Now we move on to the next feature of reproducible environments. So there is a feature known as dev containers. So dev containers are basically your container-based containers in which you have all your IDs, all your features, all your tools installed itself. So you can create a dev container and start coding right from there itself. It's pretty much popular, as we can see from the number of installs. You define a configuration in a JSON C file itself. So you can automate the environment creation using dev containers. So here's a very simple example of a dev container. So the name of the dev container is Ubuntu. It uses a Microsoft owned container image. It forwards a port that is forwards the port number 8000. And once the container is started, it executes a Python-based HTTP server. And you can write simple scripts to create open directories automatically using the GitHub CLI. Now, once these features were identified, I dialed in Jaromir, who will now walk you through the various info stealers and the malwares that we saw abusing code spaces for a variety of reasons. Over to you, Jaromir.
Okay, thank you. Thank you for introduction. So now I will talk about the malware campaign we have seen in the wild. This malware campaign was related to Stealer, which we called Delta Stealer. And it's like interesting kind of family of various different stealers written in different programming languages. And all of them were developed by the same same developers. So you can see that from the slide that the main versions of Delta Stealer were written in Rust-lang, but there have been also some other versions, which I will describe later. And these have been very likely distributed via various social media, and the installers of the malware were named or disguised as some hack tools or some game installers. So you can see some of these names like Account Generator, Adventure Island Setup, Cheat, Fortnite, and many, many others. So then when we started analyzing these stealers, they have had quite many interesting features. They contain various anti-sandboxing, anti-debugging, and anti-analysis tricks. They stole pretty much everything what was available, what was possible to steal from the browsers, and the data were exfiltrated to legitimate third-party cloud storage as one part, and also some of the data have been exfiltrated to the cloud-based IDEs, like instances of GitHub Codespace, which is related mainly to this talk. So when we open the file written in Rust-lang, and you can see it in the debugger, so usually the names are like very long, kind of like difficult to read, but after demangling, you can see that the threat actors were not very careful with renaming or hiding the meaning of their functions. So we could see there was like method or class, anti-debug, detect, browser steal data, wallet steal data, Discord steal tokens, Discord inject. So it's quite pretty clear like what was the goal of all these functions. For the anti-debugging, anti-analysis features, we would mention like some evasions of sandboxes, and one interesting one was evading, here in this case, the sandbox of VirusTotal, when the malware fetches the host name and username of that machine, and when a certain blacklisted or blocklisted username is found, as you can see it here, this username is related to, or was related at least at the time, to VirusTotal sandbox. And when we have seen the sample in running in the sandbox, it didn't produce any output because the sample immediately exited after detecting this host name. So in this schematics, I will show you like step by step what the stealer did. So here you have the sample. In the beginning, it checks the third-party cloud storage. It's called like gofile.io. It checks it for the near location or of the nearest server. So it gets the server name to which the stolen data will be later uploaded. Then starts with the stealing process. So it steals browser credentials. It steals crypto wallets. It steals another Discord, Steam data. Then everything is packed into archive, and this archive is uploaded to the previously acquired server name from the first query to gofile.io. Then after uploading, this service returns the URL link, which is used for anyone who owns the link can download the files. And together with additional information like some statistics, browser name, public IP, and so on, these data are exfiltrated to publicly exposed Codespace instance. So this instance of Codespace is used like the server to which the data are exfiltrated. And there's also a second branch, very interesting, like from the sample, that it checks if there is Discord client running on the machine, on the infected machine, and if yes, it infects this client. And every time the user logs in or enters some interesting information like credentials, credit card information, PayPal, and so on, again, everything is exposed or exfiltrated to publicly exposed Codespace instance. Now, when we analyze a little bit more in detail this Discord client, it's written in Electron framework. And for those of you, if you are like a researcher, you know that these Electron applications are usually, they contain many files, lots of overhead. So in this case, you know where to look for. So in this case, there is some file called core.asar, which is like special archive, which you can again extract. Then you can find there many modules. One of them is called Discord_desktop_core. And this module contains like many different files. And we have noticed that this module has been modified by the stealer. So when we analyze this file, you can see that there is this ASAR archive, which contains file called package.json, which is something like manifest, which specified this file, index.js, as entry point. And this file contains several another JavaScript files which are loaded. And by diffing the original non-modified version and the modified version, we notice there is like extra require of the file called /CDN. So CDN, it's not content delivery network something. It's just the malicious modification, malicious file, which later in the file, it contains list of URLs which are monitored. And these are used for, authentication of the user and so on. So the malicious version just captures the traffic which goes to these URLs and extracts relevant information from them. Later in this cdn.js file, there is forced logout. So when the user is all logged in, the malware needs to force him logout. And after the logout, the victim needs to enter the credentials, which are then captured. So then there is some token stored in the local storage. So here the script sets this token to be empty string. So the token is deleted and the application needs to authenticate again to generate a new token. Logging credentials, these are the pieces of code described on these screenshots. So every time, for example, email changes or login information are entered, everything is logged by the malicious Discord application. One more interesting thing is that many of these communication applications, they use QR code to log in. So you are logged in on your mobile phone, you just scan QR code and you log in. So you don't have to enter your credentials. So this is not good for the stealer if they want to capture these credentials. So they install or they run this piece of script and which says or which checks the protocol to WSS, which is WebSocket protocol. And there is callback cancel true. So whenever they see the connection or the using of WebSocket protocol, it's basically disabled. And this WebSocket protocol is used for this verifying or validation of QR code. So what will happen if you try to log into this infected to this infected application, that the QR code, like in here in this screenshot, it's not shown. There are only like 3 dots because the communication to this WebSocket through this WebSocket protocol is completely disabled. So the victim has to enter the credentials by typing email or mobile number and password, and these credentials are then logged in. This is the example of logging the credentials. There's usually the event. It can be one of these events, password captured, and token if it is present. Here in this screenshot, I will show a few examples of the request. So the first request is getting the Go file nearest the server, simple get request, and answer is the name of the server, simple request. Then the first case is the exfiltration of the data statistics and link of the Go file. So the Go file, after uploading the file, it returns here parameter download page is the URL of the file which will be downloaded. Another example, exfiltration to GitHub Codespaces like malicious session. Here it's very important. There is the post request, and here you can see what the Nitesh mentioned in the beginning. There is like dash port number, and domain is like app.github.dev. So this is like a running Codespace instance, which is like listening to submitted stolen information. And again, another post request, and this is again example of submitting the credentials to the Codespace. And here's the event, login password, and here's the Discord token, which I described before. So when we were running the malware on this testing machine, we have seen all these types of communication, and we captured everything with, for example, with Fiddler. There have been like few more variants of the Delta Stealer, and then some of the variants which I will quickly describe here, they were used more like obfuscation. So the main Stealer was written in Rustlang. They had the component written in Electron, and this modification or this component was injected into Discord application. But they also, the threat actors also used the Electron to make kind of like one more layer of obfuscation. So in this case, there was NSys package, which contained the installation file for Electron application, inside of AppAsar archive, package JSON, and so on. They have been like, they use this as one more layer of obfuscation. And in this case, we could notice when we open this package.json, there is the name of the stealer, Delta, and there is some key and initialization vector. So how it is used later? Later in the entry point file, main.js, you can notice that it creates encryption, AES 256 CBC mode. Then they load one file, libdelta.dll, but now it's not DLL, it's just some binary file, as you can see from the screenshot. It's like it doesn't have like any known structure. But after using all the parameters which we could easily extract, then this file decrypted to the executable file, which later contain again a SAR file to inject into the Discord client. And here you can again notice delta stealer, name of the class, and name of these functions. Another versions which we have noticed were written in Node.js. So again, it was more like one more layer of obfuscation, because Node.js, it's like tool for basically writing the code in JavaScript and in JavaScript. And we have seen like application which looked like this from visual point of view. It asked for email and password, but it had like no functionality in the background. So if user entered any information, nothing happened. But in the background, it started some downloading process. And based on the version, it downloaded either 1 or 2 files. In one of these cases, one of these situations, the file was stealer and another one was uploader. The uploader file was written in Node.js and packaged into executable with this pkg utility, with packaging utility, and it did nothing. It only took the file and uploaded. There was also another file which we found. It was stealer. It only stole some credentials, but this file didn't upload it anywhere. They just split the application in 2 different components. So now this is all for the malware analysis. But one interesting thing is that the threat actors were active on Telegram, and they had like some public chat group, and they shared like many different information. So we just followed this Telegram group, and we noticed that sometimes the actors share these screenshots. So you can see that this looks like piece of code. If you zoom it a little bit, you can see like here on the bottom left, there is the text Codespaces. So it seems that they are using Codespaces for coding their malware. Here in the address bar, you can see that there is some random name .github.dev. So this is like their Codespace instance in which they are coding. In more screenshots, we can see that, for example, they use this Swagger utility for designing their API. They call it Delta Stealer API, and there are like some screenshots from that. Again, here you can notice app.github.dev, another reference to running Codespaces. They use package utility for packaging Node.js script into executable. So here you can see this package pkg dot something. So it's again the reference to one of the malware I described before. It used different, they also tested their malware on their own probably sandboxes. So you can see here, there's a screenshot of some files stolen from, or some statistics or some files containing stolen data from their own testing machines. You can see autofill, cookies, credit cards, history, passwords. They also shared like example of the stolen cookies in one specific format, which is like Netscape format. So you can have like several different columns divided by tab character, and you can see basically the exfiltrated cookies. Now Nitesh will continue with some hunting tips. So if you want to hunt for similar threats, so how you can do it easily.
Thanks, Jaromir. So when we think of the hunting tips for Codespaces and cloud-based development environments in general, the first thing is to obviously go to VirusTotal and look for what are the subdomains that are already known. So it's very interesting to note that you can only search for subdomains that are already known. So if there are certain samples, files, or anything that is uploaded there, then you can hunt for that. But you cannot predict or find like a definite list of Codespaces out there. So you can use the behavior or the content filters as well. And based on this only, we actually started off when we found the info stealers. So there have been certain updates to GitHub Codespaces ever since we started looking into the service. So the first is that the URLs, like the subdomain for the URLs changed from preview app.github.dev to app.github.dev. So maybe this looks like a preview to the production change. But the interesting bit here is that the URLs now don't contain any username in the code space URL itself. So this is probably to hide from the network privileged attackers. So previously, it was mentioned in their official documentation that you do not have access to the outer Linux virtual machine host. And right now it is mentioned that you have limited access to the outer Linux virtual machine host. So we're not really sure, was it related to the code space container escape? Additionally, this prompt was added for users who try to access a publicly exposed code space port on someone else's code space. So this prompt is only visible from the browser. So if you're using curl or wget or some simple CLI tools, then you will not get this prompt, and it's probably based on user agent field. Now, dropping to the conclusion. So these services, especially when they are free, it offers a lot of advantages to both legitimate users and attackers equally. Now, anybody with a GitHub account could create these code spaces virtual machines for free, and they could automate the creation as well. And in this session, we described how we found the various features. And then we found that attackers are actually using code spaces to build and test their info stealers, just like regular software development is done. So the bar to create resources is very low. You don't even need a valid, like a proper email address to create a GitHub account. You can use temporary emails in that case. There is no verification on the email side of things. Now, when we think of the ease of use, it is very high, as we saw. The developer features arm attackers a lot. And as you can see in this very simple screenshots, just to show that these subdomains and these domains, these IP addresses will definitely evade your traditional defenses like IP-based reputation and all. And using dev containers and other features, you can create short-lived replicable environments. So let's say even if you found a malicious GitHub account, you reported it to GitHub, GitHub took it down, they still have the JSON-C file. They can create the environment within a few seconds elsewhere. So when we think of trust but verify, everybody loves these three words. So code can be in the form of VS Code extensions, container images that you're using in your dev containers, GitHub repositories, the dev container post start commands, and all those command execution directives. You need to be very careful when you're executing dev containers in your environment. So you can verify them. And since you can create dev containers on your local laptop as well, so there is a very different attack scenario that we are still in the process of talking about in a few months. So premium GitHub users can apply policies to control the code spaces that are created for their organization. So they can set the base image, the visibility of the forwarded ports, the idle timeout period, the retention period, the VM configuration of the code space. So all of these can be set by a policy. And segregating your dev and prod environments are super important because, for instance, your production servers should not be accessing a development environment in the first place. So these are the references that you can look into. And those are our QR codes for catching up. And that was from Code to Crime, Exploring Threats in GitHub Code Spaces.
Right, so thank you guys, really interesting. There's quite some time for questions. If people have questions, please come up to the mics.
Thank you for your presentation. It was really, really helpful. I'm Ted. I'm from S2W, and I have a couple of questions to you guys. First is that recently I've been observing a lot of stolen malwares are starting to build on Rust. So like I want to know whether like what's the advantage of using Rust, and my second question will be like, and how this Delta Stealer is distributed, like and I want to know like whether there's any like threat actors involved in this, campaigns, in the previous, like have used Delta Stealer in the past.
Yeah. So for usage of Rust, I would say the main reason for them is that when the binary is generated in Rust, I would say that it generates, you know, bigger binaries. It generates like more code. So for us analysts, it's like more difficult, more time consuming to analyze it. Because if I can compare it, for example, to C or C++, this is usually much easier. If you open this file in some decompilers like IDA-Pro, it's very, you know, easy to find the ways. However, for Rustlang or for Rust, it generates, in this case, the installer head or the stealer head maybe like, I don't know, 20, 30 megabytes. It generated like quite big file. So it took some time to analyze it. So I would say one of the reasons can be just to make analysis of us, like researchers, like a little bit more difficult. So this is for the first question. And the second question, like how it is distributed, like we think that it's distributed via some social media platform like Discord, because some of these file names, which I showed you, they have been hosted on this CDN, this content delivery network belonging to Discord. So we have seen couple of samples like this. So I believe that these guys, there are probably some gamers or people who are interested in computer games. They have probably their own forums, either on Discord, probably in Telegram, I don't know, and they share the files there. They say probably this one of these examples are shared was the file which was like some cheater for Fortnite or something. So someone probably says, oh, this is new version of the cheater, please download it. The other guys, other gamers download it, and all of them they get infected. This is most probably the way how they distribute it.
All right. Thank you. I see that's why they target Steam and Discord, right?
Yes, Steam and Discord.
All
They
right.
are the most interesting one of them because both platforms are mainly for gamers.
All right. Thank you.
In one of your slides, you were showing about this Go file API. There was a domain they were
Yeah,
communicating.
Go file, yes.
Did you also notice if they are spinning up the Codespaces before they want to upload something? Because we understand that those Codespaces lifespan is just 4 hours. So do they like bring a new Codespace up, push the file?
So the mention about exfiltrating the files to a publicly exposed port on a code space, that was what we found from the samples, because the domains were hard-coded in the samples itself. But this seems like a feature that they were testing the info stealers using code spaces. So let's say if you build some stealer, you want to test whether it's working properly or not, then they're using code spaces to test the info stealer and also test the virus total sandbox, whether, you know, when they get 0 detections, then they boast about it on Telegram, for instance.
So it's not like a dynamically generated.
Yes.
Thank you.